In an earlier video, I went over some factoring techniques for polynomials. In this video, I just want to go over how you can use factoring methods to solve some algebraic problems. So right now I'm going to focus on algebra, but you can use this also in trig. But let's look at the ones that I have here from basic algebra. So the first one says simplify. So I have a rational expression here. So basically in this case, what they want us to do is just to reduce it. So we want to factor the numerator, factor the denominator, and then divide out any factors that are common, and then that'll leave it in simplified form. So in this case, the numerator is a binomial. So the first thing we look for is to see we have a common factor, and each term has a factor of x. So we can take out an x from the two terms of the numerator. That leaves me with x squared, factor out the x, that leaves me x. Take out the x from a minus 5x, that leaves me minus 5. So the numerator factors into x times x minus 5. Now the denominator is also binomial. We don't have a common factor we can take out, so we have the difference of squares. So we noted last time, if you have a difference of squares, you can factor into the difference and the sum of the square roots, or the sum of the difference of the square roots. So in this case, the square root of x squared is x, the square root of 25 is 5, so we can write this as factored into x minus 5, x plus 5, and of course we could also write it as x plus 5 times x minus 5. Doesn't matter. Now then, if you have any factors in common, then we just divide them out. So notice the numerator has a factor of x minus 5, so this divides out with this one. Those become 1s. So x times 1 is x on top, and the bottom I just have 1 times x plus 5. So the reduced form is x over x plus 5. And this is the simplified form. Now, if I didn't have any factors in common in the numerator and the denominator, then we would simply give the original answer right here and say it's already simplified. Okay, so that's your solution to that one, x over x plus 5. Let's clear this. Now in the next one, again we have a binomial on top. The bottom has a trinomial. Now notice the top part is a difference, no common factor, but it's a difference of cubes. 27 is a perfect cube. Of course, x to the third is a perfect cube. So from the last video on factoring, we noted that if you have a binomial that's a difference of cubes, the first factor will be the difference of the cube roots. So the cube root of x to the third is x. The cube root of 27 is 3. So that's the first factor. And then the second factor is the square of the first term of the binomial. So that's going to be x squared. And then the sign changes to a plus here. The product of the two terms is 3x, so that goes here. 3x is the next term. And then it's plus the square of the second term. Okay, 3 squared is 9. So you get that. And then the denominator is a trinomial. So we try the method that I showed you last time. Is trial and error. But before I even try to factor this, and I won't be able to factor it the way it is, but notice that I got x squared plus 3x and x squared plus 3x on top. So basically those are going to cancel. So let me just write it out here. X squared plus 3x plus 9. And just I have the same thing up here as a factor. I can divide this out with this one. That becomes a 1. 1 times x minus 3 is x minus 3. So the simplified form of this problem is x minus 3. Okay. So we're using factoring to simplify these rational expressions, or fractions if you want. And let's just clear this out now. The next one is a quadratic equation. Normally quadratic equations will have two solutions. They might have one that's repeated, or they might have no real solution. And these can be solved by using the quadratic formula. They can be used, you can use the method of completing the square. You can use factoring. Now the first method you want to use is factor. Okay, so what you want to do is make one side 0. So let me just do this. X squared plus 4x. And then I'm going to add 21 to negative 21 to both sides, because I need one side to be 0. So adding a negative 21 here, that cancels out to 0, and then I get a minus 21 over here. Okay. Now, if the factoring method doesn't work, then you're going to use the quadratic formula or the method of completing the square. But here we're focusing on the factoring method. So once you have one side 0, now we have a trinomial on the left side. So we try to factor this, no common factor there, so write this out. And then x squared factors into x times x, or x and x, so I'll put that down. Factors of 21 are 3 and 7, 21 and 1. But the idea again, remember if the sign of the third term is negative, these signs are going to be opposite. One's positive, one's negative. So I can put a minus here and a plus here. And then I want to pick the combination of factors that'll give me this middle term, 4x. So it looks like 7 and 3 will work. Since I want this to come out to a positive, I put the 7 here and the 3 here, and then just kind of check it. See, x times x is x squared. That works out okay. 7 times a minus 3 is a negative 21. Minus 3 in x is a minus 3x. 7 times x is 7x. 7x minus 3x is 4x. That checks out. So now we have the product of two factors is equal to 0. The only way that the product of two factors is 0 is if one or both are 0. So all you're going to do here is just set these equal to 0 and solve for x. So x minus 3 can be 0, or x plus 7. Can be 0. So you got two equations. X minus 3 equals 0, x plus 7 equals 0. So add a negative 3 to both sides here. We get x equal to 3. Add a negative 7 to both sides to solve this for x. We get x can be negative 7. So the two solutions to this one, x can be negative 7 or x can be 3. And that's your solution. And you can easily check these by plugging them back into the original equation. Put a 3 here and a 3 here. That'll get combined as 21. Put a negative 7 here squared, 49. Negative 7 times 4 is a negative 28. Combine those and that gives you a 21. That checks. Okay? So that's the way you would check your answer. Here it is. And then on the next one, perform the indicated operations and simplify. So here you're just multiplying two fractions, rational expressions if you want here. And then we want to simplify. Okay, I want to give you answer in simplified or reduced form. So we can do this here. Okay, so we got this. So what we want to do is we want everything factored out if we can, and then cancel factors out that are like. If you have one factor on top and one factor in the bottom over here is a denominator that's the same as one in the numerator, then you can cancel those out. So for the first one here, x squared minus x minus 6, okay, using the trial and error method, it's trinomial, no common factor, so we can factor this out into x minus 3. And x plus 2. Okay, so you can check it out. X times x is x squared, minus 3 times 2 is a minus 6, minus 3x, oh, minus 3 times x is minus 3x, 2 times x is 2x, add those up, minus 3x and 2x is a minus x, that checks. And then x to the third on the bottom, that we just leave it the way it is. That's just 3 factors of x, so we leave it there. And then the operation here is divide. So you remember when you're dividing numbers or expressions, in this case, you invert the denominator and multiply. So this becomes x squared on top then. You're inverting it. Okay. And then the x squared minus 3x will go to the bottom, but notice it has a common factor of x, so we take out the x. And that becomes x times x minus 3. And then you can cancel any factor that's on top with 1 in the bottom. So notice I got an x minus 3 in the bottom, so those will divide out. So those becomes 1. Okay, you can just cancel them out. And then here you got an x squared. Here you got an x to the third. So this is going to divide out into this, and this is just going to leave me an x. Okay, 2 factors of x, and here I have 3 factors of x. So I'm left with 1 factor of x. So your final answer then for this one, what do I have on top? It's just 1 times the x plus 2. So this is x plus 2. And then in the bottom I just have x, and this is an x here. So I have an x here from this one, and then times this x is x squared. Okay, and that's as far as I can go as far as the simplification. Okay, x squared and x squared, and then I had this x over here to multiply this x over here. I got x squared. It's just what we got. Okay, now again, you can also apply factoring like this on trigonometry. Okay, except you're dealing with trig functions, but the procedures are still the same. We'll pick it up there next time. Thanks for watching. See you in the next video.